Hi students, welcome to the second session of online classes. This class, I would like to revise what I discussed in the earlier class. So, I was talking about light, that is rectilinear propagation of light, reflection and refraction. So, in this chapter, the very first topic we need to discuss that the rectilinear propagation of a light. It means the straight line propagation of light. We are considering light is traveling in a straight line. That's known as rectilinear propagation of straight line. That's why we used to represent the light as suppose if this is a light source. So from this light source we are representing a straight line as arrows. So these arrows will represent the light ray. So to understand the better, the first concept in this chapter we discuss the reflection of light. Reflection of light. If you take as in a plane mirror, suppose if this is in a plane mirror, so this is non-reflecting surface. If you draw a normal to this plane mirror perpendicular to the surface, an incident light, a light which is falling, an incident light, and this will become as a reflected light. So according to the laws of reflection, the angle of incidence, angle made by the incident ray to the normal angle I equal to angle R. So angle I equal to angle R. And the second one, the incident ray and the reflected ray and the normal, they must lie in the same plane. So the incident ray and the reflected ray and the normal, they all must lie in the same plane. So that's what I discussed in the reflection of light. Coming to the, because of the reflection, image will be the form. Okay. So to form an image, we need some objects. Those are known as mirrors. Mirrors, they can form images. So mirrors are three types. One is plane mirror, another one is convex mirror, and another one is concave mirror. Plane mirror, convex mirror, and concave mirror. So plane mirror, convex mirror, and third one concave mirror. So in this one, convex and the concave mirror, they called as spherical mirrors. Spherical mirrors. Because to make convex and the concave mirror, it has to be made from a sphere. So they are having some curved surface. So for convex mirror, first we need to make a sphere of dotted circle. So in this one, if you can cut a portion, a particular part, if you cut particular part on the mirror, you can cut at the here, and you will get this remaining portion. Okay. Now I got this particular shape. I got this particular shape. So in this particular portion, if we can make this is a non-reflecting surface, means if this is a curved surface, if this is a curved surface, to this curved surface, if we can make inside is painting and this surface is reflecting surface. So this mirror is known as convex mirror. Or if you can take another mirror, same, you can take the spherical surface. Now we take as a spherical surface, draw a sphere, now draw a sphere. Now in the sphere, now you set on this particular portion at here. So in this particular portion, if you paint, if you paint outside this surface, you will get a particular portion on the mirror, so that is the same curvature will be there, but the outside portion is painted. The outside portion is painted, so that portion, this painted portion is non-reflecting surface, and this is known as concave mirror. So mirrors are the spherical mirrors are the two types. One is the convex mirror, another one is concave mirror. Convex mirror and concave mirror, these two mirrors we are known as spherical mirrors. Let us see some terminology we learned in this ray optics. That is, first make a sphere. So in the sphere, it will be the center of the sphere. The center of the sphere and the distance. So this is the center of the sphere. We denoted with the capital C. And this capital C is also known as center of curvature. And the distance from the center of curvature to the edge is known as radius of curvature, capital R. Suppose if you are making this is as a mirror portion, so this particular height we can take as a mirror part. So this is we are known as aperture. And the center of the mirror is known as PO. An imaginary line which is connecting center of curvature and the pole is known as principal axis. An imaginary line which is connecting center of curvature to pole is known as principal axis. Here one more point will be there. The midpoint between the center of curvature and the pole and this portion we known as focus. So these are the terms we learned. C stands for center of curvature, and R is the radius of curvature, and P equal to pole, F equal to focus, and principal axis, and last one is aperture. Let's see some of the rules to draw ray diagrams. Among that, for the first one, representation of images formed by spherical mirror by using ray diagram. So we need to draw certain rules for the following representation. The first one, the very first one, a ray parallel to the principal axis. After reflection, it will be passes through the principal focus in case of a concave mirror. So this is the concave mirror. So this is a ray, if it is a concave mirror, this is the principal axis. Now a light ray is a parallel to the principal axis. After reflection, is supposed to be passed to the focus. So this is the first rule we are using to draw the ray diagram. The second one, a ray passing through the principal focus of a concave mirror, and after reflection it will be parallel to the principal axis. So it means it is opposite to the above the case. I am only discussing for time being concave mirror. So the rule you can take, suppose if we take as a concave mirror, so this is the non-reflecting surface on this side. Now this will be the principal axis, and here will be the center of curvature, and here will be as a focus, and between the point we will take as a focus. Now a ray which is passing through the focus, a ray which is passing through the focus, after reflection it is parallel to the principal axis. After reflection it is parallel to the principal axis. One thing please keep in mind, so these rays should not be bent like this. So here in the digital manner it is coming like that. So here should be perfect lines it's supposed to be. Otherwise there is no meaning of the rectilinear propagation of light. And the third rule is that a ray passing through the center of curvature, a ray passing through the center of curvature, after reflection it takes the own path. Now for concave mirror, draw a concave mirror, same concave mirror. If this is the principal axis, if this is center of curvature, a ray which is passing through the center of curvature is the incident ray. After reflection it takes the same path. And fourth one, I discussed the same rule. This is the fourth rule. A ray incident obliquely on principal axis towards that point P, pole of the mirror, for a concave mirror. After reflection, so it follows the law of reflection. It means angle of incidence is equal to angle of reflection. So here incident ray, how you draw that one? Draw a concave mirror. So if it is a concave mirror, this is non-reflecting surface, and this is principal axis, and if it is the incident ray and this is the reflecting ray, if a light ray strikes at pole, it follows the angle of incidence. It means angle I equal to angle R. In this case, angle I equal to angle R. So these are the rules we will use to form an image, for time being, I discussed about only the concave mirror.